Hi, everybody. I'm Karen Meigs, co-director of Learning Centers here at Lindamood-Bell. Thanks so much for joining me today. I am looking forward to talking with you about what we know about how gaps in conceptual understanding can impact math and how we address those gaps in the On Cloud 9 program for math. So let's start by looking into a little bit about how we got to where we are today. This is Nancy Bell, our director and CEO, still very actively involved in all of the instruction that we do. And you see Nancy here with Pat Lindamood and Pat's daughter, Phyllis Lindamood. Pat and Phyllis co-authored the LIPS program together. Nancy Bell and Pat Lindamood started working together in the mid 1970s. Pat was a speech pathologist and Nancy a reading specialist, and they started working together, founding Lindamood-Bell in 1986, along with Charles Lindamood here in San Luis Obispo, California. They researched and authored the all of our internationally acclaimed programs: LIPS, Seeing Stars, Talkies, Visualizing and Verbalizing, and On Cloud 9 for math. Over the last 40 years, Lindamood-Bell has assisted thousands, tens of thousands of individuals to learn to their potential in our 46 learning centers throughout the United States and UK and Australia. We also work with students all around the globe via live online instruction. Pat Lindamood and Nancy Bell started to work together in a clinical environment and working with, again, thousands of students of all ages. All were experiencing language and literacy challenges and have been able to integrate their experiential knowledge and the research. And what we have learned is that reading is an integration of processes and that the primary goal is comprehension. For over 40 years, students of all ages and backgrounds have come to Lindamood-Bell experiencing failure and frustration in school. The question that we were asking was, why did some students succeed and others did not? What was the primary cause of these weak language and literacy skills? Decades of peer-reviewed research and working with individuals of all ages has enabled us to learn about that primary cause. We know that the brain can only process sensory information, and we know that some individuals have strengths in sensory processing while others do not. The primary cause is at the sensory level. We believe that the sensory input of imagery underlies competency in language and literacy skills. Carl Pribram said, "We cannot think about something of which we are not consciously aware, and we cannot be aware of something not perceived sufficiently at the sensory level to come to consciousness." Nancy Bell says, "Imagery is sensory input." Our On Cloud 9 math program, along with our Visualizing and Verbalizing program, is based on a theory of cognition called dual coding theory. Dual coding theory was researched and developed by Dr. Alan Pavio, a cognitive psychologist. And Pavio said, cognition is proportional to the extent that the coding mechanisms of mental representations, that's our imagery, and language are integrated. Performance is mediated by the joint activity of verbal and nonverbal systems. Cognition is always an interplay between the verbal, that's language, and nonverbal systems. This is imagery. Pavio went on to say that imagery includes not only static representations, but also dynamic representations of action sequences, relationships between objects and events, and that individuals all differ in the extent, manner, and efficiency of how well they use each of these systems. Albert Einstein said, "If I can't picture it, I can't understand it. Some of the weaknesses that we see, symptoms of math weakness, and we see in the students that come to us are uh, weak concept imagery or weak symbol imagery or both. We might also see that they have weak math test scores, difficulty with word problems, show instability in their math facts, or are mixing up the signs and symbols in math equations. You might see that they can do the work when they have a sample provided, but without that sample, they struggle to complete the problem. And you might also see that they have difficulty with applying math to real life, or difficulty with recognizing and noticing patterns. So why is it that math is so easy for some and yet so difficult for others? And so many of the other students are experiencing some of those symptoms that we just looked at. Well, we know that mathematics is cognitive processing, it's thinking, and therefore it requires the dual coding of imagery and language. Imagery is fundamental to the process of thinking, and that includes thinking with numbers. Imagery is a sensory cognitive function, and sensory cognitive functions are the foundation of language and literacy skills. So let's learn a little bit about those sensory cognitive functions, and then we can talk through how they apply to math. The sensory cognitive function of phonemic awareness is the ability for us to auditorily perceive the identity, number, and sequence of sounds within words. We use this, is one of the sensory cognitive functions that we use to do word attack, or to decode, to sound out words. We also need to use, in order to do word attack, we also need to be using symbol imagery. Symbol imagery is the ability to image, to picture, visualize the identity, number, and sequence of sounds and letters within words. So we use this for word attack and for sight word recognition. This, if phonemic awareness is being able to auditorily perceive the sounds and letters in a word, symbol imagery is our ability to picture and visualize the letters in words. And that is a little bit different than concept imagery, in that concept imagery is our ability to image a gestalt, the whole, for oral or written language comprehension and for critical thinking. So symbol imagery, being able to picture the parts, the letters, and concept imagery, being able to picture the whole and the meaning. This is the dynamic representation that Pavio talked about. You can see in this Venn diagram that we believe that these three sensory cognitive functions underlie all of the component parts of reading. So in reading, we know that there is an auditory component that is what we use in order to do word attack, to sound out new words. There's also a visual component, which is what we use to do sight word recognition, and a language component where we integrate contextual reading and fluency. We also know that the goal of reading is to be able to understand. The goal of reading is to comprehend. And so that's our outer comprehension circle. Well, the sensory cognitive functions that underlie these component parts, with auditory processing, we need both phonemic awareness and symbol imagery. Visual processing requires symbol imagery, as does language. Our outer comprehension circle, this is where we're relying on concept imagery to support that. So a quick refresh of our two types of imagery. Symbol imagery, the ability to image the identity, number, and sequence of sounds and letters in words. This is Buzz here, picturing the letters in the word clown. He's picturing the parts of the word. And Natalie over here is demonstrating concept imagery. Concept imagery is the ability to image a gestalt, the whole, for language comprehension and critical thinking. You can see that she's got imagery for a clown. She's picturing the colors, the size, the shape. There's movement and sound and energy in this very dynamic representation of the word. On Cloud 9, what we are doing is integrating and applying principles of both the Visualizing and Verbalizing program and the Seeing Stars program in order to access imagery as the foundation for mathematical processing. So the symbol imagery development, we use Seeing Stars as the primary program to develop this, whereas we develop concept imagery using the Visualizing and Verbalizing program. So in order to do math, we are pulling on Cloud 9, we are pulling from both Visualizing and Verbalizing and Seeing Stars as the foundation. Mathematics is cognitive processing. It is thinking, and therefore it requires the dual coding of imagery and language. The imagery that we're using on Cloud 9 is both numeral imagery and concept imagery. This is our sensory system's way of making abstract concepts real. And it is why strength in imagery is so critical for math. So we use numeral imagery. This is our ability to mentally create and access symbols that represent the reality of numbers. We're to be able to visualize the numeral symbols as one of the basic cognitive processes necessary to understand math. We have to be able to picture the number 2, the number 4, the number 627. We have to be able to picture the multiple symbols that indicate multiplication or division, and we have symbol imagery, numeral imagery for those math concepts. We also use our concept imagery in math because we have to be able to image the gestalt or the whole for the big picture in order to understand the processes underlying mathematical concepts, the logic and the reasoning behind it. We also need concept imagery in order to help us with processing a word problem in math, understanding what the question is asking us and what information is relevant and how to turn these words into an equation. When you think about what math instruction often looks like in schools, in early grade levels, it's very heavy on utilizing manipulatives. We have cubes, we have blocks, we have images that represent 2 apples plus 1 apple, and we use these physical manipulatives to keep the information concrete. And then sometime around 3rd grade, you start to see a shift in focus, and we shift from that concrete use of manipulatives to doing pencil and paper computation on the page. So students are being expected to automatically progress from those concrete manipulatives to abstract computation, and often the imagery connection that is required here is just assumed to be intact. So how is it that some children are making this transition from the concrete to the abstract with ease? They have the imagery language connection is intact for them, but it is assumed to be intact for so many students who actually don't have strong enough imagery to support that transition. And that is exactly what we're developing and working on Cloud 9 instruction. By developing numeral imagery and concept imagery, we are establishing this imagery language connection for math. So in bringing concept and numeral imagery to a conscious level on Cloud 9, we are integrating and applying principles from Visualizing and Verbalizing and Seeing Stars programs and moving through 3 basic steps. We have the first step is experiencing realness at a concrete level and utilizing manipulatives in order to do that. And before we make the leap to computation, we have this very important step of concretizing the realness of that we were using with manipulatives, using into our imagery and into our sensory system. And then we would, as a third step, then transition into computation and applying both the imagery and the language to the paper. We move from the concrete to imagery to computation in all steps of On Cloud 9. Imagery is the missing link. Students are, the way that we're doing that is students are questioned and directed to transfer that concrete experience that they got by using the manipulatives to their imagery, and then they attach language to their imagery before moving into step 3 of computation. Imagery is our sensory connection to language. I want to make a note that it is very important, it's essential, that the sensory cognitive function of concept imagery needs to be intact for students prior to them developing their mathematical processing. So the On Cloud 9 program, or any math program, you may see a student reach a plateau in their progress if the students have a weakness in concept imagery. And you may need to do instruction in either the visualizing and verbalizing or seeing stars programs, or both, in order to adequately develop their concept imagery and symbol imagery before transitioning into On Cloud 9 instruction. It is very important. Students need to be able to access both forms of imagery in order to apply them to the mathematical concepts and processing that we're doing in the On Cloud 9 math program. Let's look at some of the research results for On Cloud 9. These next couple of slides that you're going to see are based on data that we've collected in our learning center. So between January 2008 through December of 2025, we in pre and post testing for students that received at least 80 hours in the On Cloud 9 program, you can see that on average, these students completed 108.5 hours of instruction. Our norm group was 140, and our average student was about 11. On the TOMA computation test, this is the test of mathematical abilities, the average percentile increase moved from the 9th to the 37th percentile. On the TOMA story problems assessment, students moved from the 19th to the 34th. And on the wide range achievement test for math computation, students moved from the 13th to the 42nd. This is in 108 hours of instruction. We are seeing that our students in On Cloud 9 are moving from area of weakness to a normal range in their math abilities on these assessments. These average standard score changes for the same group of students. This is a 14.5 for the TOMA computation, and story problems average change was 6.7, and on the RAT computation 13.9. So we are seeing significant progress in the post testing that we've done with our students. We also worked with, this is from the 2011-2012 academic year, Lindamood-Bell partnered with Fairmount Elementary School in Tennessee. This is a Title I school, 79% free and reduced lunch, and we worked with a group of 41 students who completed instruction in On Cloud 9. The average number of hours was only 47. Compare that to the group of 123 students who did not do instruction in On Cloud 9. And what we see is that our On Cloud 9 group made an average standard score change at 8.8, which is considered a large change, compared to 3.1 medium change for those who did not receive instruction in On Cloud 9. And the last study I'll show today is was a project that we did with Georgetown University. So we had 31 students between the ages of 7.5 and 12.5. They were placed in groups doing instruction in either Seeing Stars or Seeing Stars and on Cloud9. And what we saw here is that these students who were part of our math intervention made significant standard score changes in comparison to those who did not receive the math intervention. There were Overall, the students made strong gains in both reading and math performance, which were the two skills developed in the intervention. And the control math intervention resulted in gains on math, but not on reading. So we are seeing behavioral changes, growth in reading and math that were specific, significant, and enduring. Let's talk a little bit more about what the On Cloud 9 program looks like, starting with understanding the whole here. The gestalt of On Cloud 9, remember, is to stimulate the mathematical dual coding of imagery and language, sensory cognitive processing with numbers that can be applied to all mathematical learning. The parts of the program or the individual steps will be represented in a math ladder. We start at the bottom rung and we work our way up with the goal of developing thinking and reasoning for math. This is what our math ladder looks like. You can see we start down here with imaging numerals, imaging a number line, and then we build our way up all the way to word problems and carrying and borrowing and up to fractions. Fractions has its own ladder, starting with conceptualizing what is a fraction and working our way all the way up to being able to divide fractions. And remember that each step of the way, we are doing the concrete portion and then the imagery portion before we transition to applying that to the abstract computation on the page. This is the another way to look at the steps of On Cloud 9. This is just the progress chart that's included in our kit. But same steps, working from imaging and writing numbers and number lines and working all the way to fractions. And there are a couple of key elements to success in the On Cloud 9 math program and the instruction that we do. One is the way that in all of our programs that we do error handling and we are responding to the response. So Seeing Stars, Visualizing and Verbalizing, LIPS, Talkies, and on Cloud 9, we use a Socratic teaching approach to develop the sensory cognitive processing. It's the teacher is going to question in order to get a response. And then in order to stimulate the student's thinking, the teacher will respond to the response and help the student compare what they said to the original stimulus that was given. This is how we develop, one of the ways that we're developing sensory cognitive processing and building to independence in reading and spelling and in math. So, for example, we have a teacher asks the student to count by twos, and the student says 3, 5, 8. And so the first thing that our teachers are going to do is provide positive feedback and point out something that student did right. In this case, it might be, it was great. Great job. You skipped numbers when counting by twos. Well done. And then responding to the response. So the teacher is repeating the student's response. You are showing me that 8 is 2 more than 5. And comparing the response to the stimulus, let's check with these cubes and this number line and see if that matches counting by twos. This allows the student to self-correct. They are verbalizing as they self-correct. So the student is saying, well, 2 more would be 7. So 3, 5, 7, 9, and they are able to compare the response that they gave to the stimulus that they received, and they are able to self-correct and therefore move closer to being able to process and independently. It is going to be important that students who do on Cloud 9 instruction have some basic concepts. We are consciously using language and imagery in each step. And so there needs to be some understanding for concepts like up, down, backwards, forwards, before, after, more, less. And so again, you may need, in some cases, students should do some visualizing and verbalizing instruction before they start on Cloud 9. But it may also be that you can do some steps of visualizing and verbalizing prior to individual on Cloud 9 steps. And that would look like the teacher says and models the movement, and then the student says and does. The next step would be that the teacher says while the student visualizes, verbalizes, and then does. And then finally, the student would be able to apply that concept to paper independently. It is important that on Cloud 9 instruction and any instruction that we're doing when we're working to develop these sensory cognitive functions is repetitive, explicit, daily instruction. We need that in order for these students to be able to establish automaticity for these math facts and math concepts. The steps of On Cloud 9 can be done in a small group or classroom instruction, or it can be done one-to-one. The steps don't need to be modified in any of those settings. You would just change your group management techniques. And lastly, it is really important that we are giving small rewards immediately and constantly, consistently giving feedback for positive responses or behaviors. In our learning centers, we like to use magic stones, and we are just dropping stones into a bucket or sliding them across the table just throughout the entire session that we're working with the students to let them know that they are doing a great job participating and showing great engagement. I will wrap things up today with a quote from Elizabeth Hainstock from Teaching Montessori in the Home. I hear and I forget. I see and I remember. I do and I understand. Thank you so much for your time and for being here today. Please feel free to reach out to us with any questions that you have, or if we can be of any help to you. If you have any interest in learning more about On Cloud 9 or any of the instruction that we're doing here. Thanks so much. Have a great day. Bye.